Hi, how's everyone doing today? My name is John Munoz, and today I'm going to talk to you about my final Capstone project, Live Member Face Recognition Deployment. Alright, so the agenda today will be a slight introduction, a system overview, model comparison, Hugging Face Spaces, and the employee website that I created. So how many times have you gotten frustrated going to places like Costco, Sam's, and sporting events and need to verify your membership manually? Well, the purpose of this project is to develop a more efficient way to verify membership and grant access while avoiding unnecessary delays. This issue exists in places like Costco, sporting events, and other venues where there's a long queues just to validate entry. So the goal was to eliminate long wait time by allowing members to gain access through facial recognition, reducing the need for manual verification. So last semester during Practicum 1, at the end of the semester, I created a real-time face recognition system using Yolo version 8. This was a great way to detect members on my local computer, but I wanted it to where I can expand it where anyone can go in and see the results and do the models. So for Practicum 2, I had really two purposes that I wanted to accomplish. Purpose one was to give the ability for anyone to go in, add themselves to this member facial recognition project. And then the purpose two was where employees can validate members in real time via a webcam or on the website facedetectiondemo.com. So on this slide, this is a demo of what I'm going to talk about, what I built. On the left-hand side, we have the dashboard, which has a couple tabs where you can add a member, add images, build the webcam, do the predictions, and you can upload a video for predictions. And on the right side is the app that employees can use. They can go to facedetectiondemo.com, and then they can click this button, try to live demo, and it's going to be in real time. So really quick, a quick system overview of what I use for my project. I use sqlite for the members database. I used OpenCV. I used Yolo. I used Hugging Face Spaces for the dashboard. I used Cloudflare, and I used Flask to create the employee app. So really quick, this is just a high-level overview of the dashboard on how it works. You see how it starts the app. You can add members, you can capture images, you can train the model. There's live recognition and there's video prediction. So if you really want to get into the weeds, this slide kind of explains the whole flow of the dashboard. So this is just a quick diagram of how the employee app works. I'm using Flask for my personal computer to show the images and train the model. And then I'm using Cloudflare to actually take that Flask and from my computer to tunnel it to the web so anyone can see what it looks like in real time on a webcam. And this is kind of a diagram for that. Alright, so what models did I train? Well, I trained two YOLO models for this project. I had a large YOLO model and a small YOLO model. The large YOLO model contained around 14 individuals and had an average around 300 images per class. In contrast, I trained a small YOLO model which had fewer members, around 7, and it had an average of 100 images per class. You can see the slides, the difference between the images. All right, model results. So in computer vision, we use this metric called maybe 50, and it's kind of like adjusted R square. So in comparison, the large model had a maybe 50 around 90%. So it means on average, it detected 90% of objects correctly. In contrast, the small model had a 85%. So it could classify objects 85% correctly. All right, confusion matrix. Well, overall, both models achieved very similar accuracy. The large model had a little bit better accuracy, but you can see here that it was able to detect some classes better than the others for both models. You can see here for the large model, Angela had a 97% recall, and then you can see some classes weren't doing so well. You can see Will had kind of around the lowest, around 68%. In contrast, on my smaller model, Dad was pretty much perfect on that class. But you can see here Juliana did a little bit worse. So some classes had better accuracy than others. So here there's just a slide comparing the large yellow model and small yellow model of how the images were trained on my volunteers. So what I ended up going with was the smaller model for Hugging Face for cost efficiency and speed. So I choose to go with the smaller model. So really quickly, I'm going to talk about how to set up your Hugging Face space. So the first step, of course, is to complete your profile. And once you have your profile completed, you're going to create a new space, and then you're going to select your SDK. I'm using Streamlit to create my dashboard, so I selected that. And then for the space hardware, at first I just selected CPU, but I'll later change that to a GPU. So your next step is to, on your local computer, get all your stuff stored into a local folder and have all your applications stored there. And then you're going to push that to the Hugging Face space. So once all that information is stored in Hugging Face under Files, you're going to create a space like this. That's what my space looks like. And then you're going to select, for my project, I'm using a GPU. So I selected the GPU for that. Alright, so this is kind of like the end result of how to get your data in there and what it looks like once you create that space. So my space is located at Hugging Face Spaces with my name / face. And so the purpose of this is anyone can go add themselves to my project and perform facial recognition, either a webcam or uploading a video. And due to cost issues, it's currently running on a CPU, but if I want to switch it to a GPU to make it faster, I can. So really quickly before I show the demo of what the space looks like, this is kind of overall flow again on the diagram where you start the app, where it loads the model, it loads the YAML face, and then you go through each one of these steps. You're going to add yourself to it, where someone goes in and fills out a form, and then you're going to save yourself to it, and it's going to update that YAML file for the members, and then we're going to capture images. Right now it's capturing 150 images from the webcam, and then you're going to add yourself to the model, and the model is going to train, and then once it's done training you can do live recognition, and then you can upload a video if you want to. Alright, now the fun part. I'm going to quickly show you how this looks to actually go through this Hugging Face demo. So basically you're going to come into my space, and then once you're in the Hugging Face space, you're going to start adding yourself as a member. So you can see here I'm filling out some fields. I'm filling out the address, filling out the email. I'm going to put your name in there, your loyalty points, your phone number, what type of membership you might have. You might have a gold membership, a silver membership. It just depends on the person. How long you've been a member, your age, also your date of birth. Put that in there. Your gender, male, female, and your status. If your status is going to be active or inactive, the goal is for the predictions to determine if the member is actually an active or an active status. And then you're going to put your interests and then your marital status. And once you hit submit, you're going to add yourself to the database, and then you can delete yourself too if you messed up and want to start over. So once that's done, you're going to go to the add images where the webcam is going to open, and it's going to take 150 images of your face. So you can see here it's just starting up, and then once it's starting up, it's going to show you the images up top of it taking your face, and then we're doing 150. And so then it's going to stop, and then you're going to go to the build model section, and so you're going to click the build Yolo data. So it's going to take those images, it's going to use an algorithm to detect the face. Once it detects the face, it's going to draw the bounding boxes around that, and then it's going to upload and train the model. You can see here the model just finished training, and you can kind of see the results over here. You can see the adjusted R-squared. It detected my face pretty well, around 99% on there. So now that the model is trained, the next step is to actually go through and do the predictions. And you can see here that's kind of the results of the model working. So now we're on the predictions webcam. So you can see right now I'm running that, and then you can see right now it's detecting me as an inactive member, right? It's drawing the red around my face that's saying, hey, you're not a member, you're inactive. It's also showing some field variables about the person. So you can see my ID, my name, my address, some of those variables that we created to add yourself to it. We also have the predictions upload video. So if you want to go in and actually upload a video yourself, I want to see if in this case, did it detect any of my old members, right? Was it able to do that? This was one of my volunteers, Juliana. So you can see here, we uploaded the video, and right now it's actually making the predictions on the uploaded video. And I'm about to see that in a second. All right, we're downloading the file right now. And there we go. Here's the video we just uploaded, and you can see it's doing the predictions right now, Juliana. It's saying she's an active member. The confidence score. It's also drawing some of the bounding boxes around there. And then this is just another example of someone else. So what happens, right? We added one member. Can we add another member at one time? We're doing that right now with someone else. It's a person named Keith. You can see here's just a made up example right here. It's detecting its face, just running through the same process again. Done collecting images. And there you go. There's Keith added to our model. It has adjusted our score around 94%, and now we're just going to run that over again, the predictions webcam. There you go. There's Keith detecting him. Pretty high confidence level. Here's me again. See if it's actually remembered that, yeah, there's me. And then the next thing we can do, you can actually hit show results down here after you hit stop, and we'll give you a table and show you the predictions and who's the highest detected. In my case, it was me. Snapped an image of myself, some of those fear variables. You can see 344 detections all were made for me, so it's doing a really good job of predicting myself. Here we're going to do the same thing, kind of predict the upload video and see if it can actually do it on the new person we add, Keith, or me. In this case, it's just me. Let's see if it works. Alright, right now it's running in the background for the video we just uploaded. And there's the same thing, there's my predictions. And right now we're about to download the video. And there I am. Just doing a pretty good job of detecting myself. Pretty high confidence score, showing you those field variables. Let's see, I'm about to run Keith. And let's see how it does. Alright, we're downloading that video right now. There's Keith. There you go, it's doing a pretty good job protecting him. And this is kind of how you want to add a GPU. This is where you go in the settings, you can add that GPU right there. So the final part of my project was for the employees, right? So right here is the face detection verification. The idea was you would walk into a store, you would have a webcam or a video field, and they would go to my app or my website, click that in real time, and then you can see here it detects the person in real time if they're a member or not. So the goal was for, instead of manual verification, using facial recognition for verification for members. So right now I'll give you a quick demo of how that works. So like I was saying before, I have Flask running on my personal computer, which has the model and it has the volunteers and it's the Python script. So first step is to run the Flask app. So right now I am going to run this app and it's going to be running on my personal computer. So we're going to run that real quick. And then you can see here right now it's currently running on my personal computer. But how do I take that personal computer website and get it over to the internet? So that's what I'm using Cloudflare to do that. So I'm saying, hey, Cloudflare tunnel, run face detection. So now it's taking that and now it's live on the internet, real webcam feed. So when the employee clicks that right there, goes to the website and clicks try the live demo, it's going to see the current feed from my webcam. So right now you can see this is the same thing, it's detecting myself in real time. So that's kind of how the employee would see it through their phone in real time using a tunnel to take it from the personal computer to the internet. You can see here it's kind of doing the same thing, detecting me, showing some of the feeder variables. And then you can see here it's also detecting other members in real time. So it's not 100% accurate. You see there it's kind of messing up a little bit, but overall it has pretty good accuracy. And here I am with another member predicting at the same time. All right, so what are the future implementations that I wish to accomplish in the future with this, right? Improve the webcam speed. It's a little bit of a lag, so I like to improve that a little bit. Enhance model accuracy. Try out other models that are made for better accuracy for face detection, maybe a MobileNet model or some better CNN models. Persistent member storage. Right now, I'm not saving when you go add a person, that session ends. It's not saving that. It restarts every single time. So to change that, I would like to have persistent member storage. And then implementation of an auto sync of member data, getting backups and files like that in case it fails. Well, I hope you enjoyed my presentation. And here's my GitHub, my Hugging Face, and then that website I created. I really appreciate your time. Thank you.